done the quiz already?
No, I've looked at it, and I
Okay.
was taking a stab at it, not successfully.
Gotcha. Make a scatter plot. Oh man, which spreadsheet had the scatter plots? Is that the quantitative?
Procedure, linear regression. I mean, honestly, you can do a scatter plot outside of that too, just in Excel, but this is the one that'll populate a scatter plot.
Yeah, I was just hoping for the one that populated it when I put the data in. That wasn't it. Which one was it called? What was it again?
Q-test linear regression. It's the fourth tab in the quantitative inference procedures.
Which one did I pick? Quantitative. I thought I picked the quantitative one. What did I take? Oh, I did categorical data. Okay, whoops, that was my fault. Where's the quantitative? My gosh, I can just hear my kids making messes out there. I need a break from classes. My house needs a break from classes. Shoot, that's not where it is. Is it here? Oh, come on. Where did I? Oh, you know what? It's under downloads. Sorry, was this quantitative descriptive or quantitative inference?
Quantitative inference.
Okay, thank you. Okay. The linear regression?
Yep.
Right? And yeah, I don't want this one. So we're doing the score and the confidence rating mean. Right?
In what?
Oh, sorry. In the math self-efficacy thing. Oh, wait, maybe not. Respond.
Still, it's got to say 3 through 5.
Yeah, Jake, I need to check it first. You're going to have to wait till I'm done with my meeting, and then I'll check it. I will go check it, though, because I need to verify it's done. You put your soccer cleats away? Okay, that's not done then. Okay, so let's go. Sorry, so up to number 3. I'm jumping ahead. So for number 3, it was 2.0 based on the text. It was saying that the y-intercept is it's b sub 0. I don't know how they pronounce that, but
that's what I was thinking. And I was watching another group video, and for some reason they were saying 1.34.
I don't know why, because you're not solving it. You're just stating which one is the y-intercept. And according to the reading, am I missing something?
Yeah, let me watch that segment again real quick.
Hello, this is Brother Kumar from the Math Department at BYU, Idaho. And these videos, I will be covering simple linear regression. And so here's the outline for these videos. First, I'll cover so first of all, the difference between a of explanatory and a response variable. An explanatory variable is used to predict the response variable. And other ways to describe the explanatory variable is also the independent variable or the x variable. Now the response variable is also referred to the dependent variable or the y variable. Okay, so if you're going back to these here, the x and the y, the x variable would be.
Oh, that's why. Never mind.
What was it?
They must have been talking about the study assignment, not quiz question.
Oh, okay.
So never mind.
Okay, cool. I was like, man, I missed something.
So 2.0 and 1.5.
Yep.
Okay.
And then 5 is 3.7 when you plug in 16 into the x place.
You got what?
I got 3.7.
So isn't a quarter of 16 4?
Yeah.
And then
Minus 3.
You're adding -3.
How did that work out? Hold on. I know it's 3. Oh my gosh. Minus 3. It's only 1. How did I get 1? I did that one in my head. I must type something else. Kind of funny. Okay.
Okay.
Yeah, that was just looking at the wrong thing. Okay. So number 6 is what I was working on, the scatter plot.
There are images in the text. So I had hot dog shape. Those 3 images are called out about 3/4 of the way down. It's got a hot dog shape, a hamburger shape, and a banana shape.
Yeah, it's more of the hot dog shape. I'm thinking. I mean, yeah, looking at it, it looks like the hot dog to me, which sounds super weird to even say, but whatever.
Yep. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? The text said about the hot dog, conduct regression analysis to determine if there is a significant linear relationship. So it sounds like you can, because the other two say linear regression is not a but that one sounds like it can be. And so I was thinking,
so A?
Yeah, that's what I was thinking.
Yeah. How many observations are in the data and what is the y-intercept?
I couldn't find how many observations in the data.
Isn't that just is that just the count of the wait.
Is it a count of both or just one?
That's what I was trying to figure out. If it's, does it tell us? The text, most of the time the text tells us if we just kind of keep going.
So is the y-intercept 18.69?
I'm not sure yet. Wait. This is an awesome paragraph. If you have a situation in your profession that involves a curvilinear relationship, you can consult a statistician, basically. You can't do that.
There are 139 line items. I don't know if that's the number they're looking for or not, or if it's double that.
Yeah, I'm looking to see if it tells us how many to use. Notice that.
The word observation is anywhere in the text.
Huh?
The word observations isn't anywhere in the text.
Right. I'm trying to figure out, like, if they're saying it's all the, excuse me. is the let me see. Whoa, Nelly. Okay. Oh my gosh, those dogs. Why do I have dogs? How many observations? How do I? What? How many? Well, I guess we could choose one or the other, and then if it's wrong, choose the other one. Mhm. I don't know. What do you think? You think it's all of them, or do you think it's half of them? Let's see. What they're doing is they're looking at. So they're observing it how many times? I guess that's what we need to think. I need to think it through a minute. Then if they're observing it.
How to count the number of observations. Data set. Let's see what Google gave me.
How many?
When we get the scatter plots later on the horizontal axis, and the y variable is the vertical axis. Okay. Now, example 1 is we want to predict body length of a crocodile using the head length. So the explanatory variable would be the head length, because that's what we're using to predict. And the response variable would be the body length, because that's what we're trying to predict. So we're using head length to predict body length. So therefore, the explanatory variable is head length, the response variable is body length. Now, if you want to, please stop the video and determine this example. Does the number of powerboat registrations affect the number of manatee killed? What's the explanatory variable and what's the response variable? Well, the explanatory variable is the number of powerboat registrations, because that's what we're using to predict, and the response variable is the number of manatee killed. That's what we're predicting. That's what we're trying to predict this based off of the powerboat registrations. Okay, so the next item is the linear regression equation. Okay, this is the general form of a linear regression equation, where it's basically y hat, which is our predicted y, is equal to beta naught, where b naught where b naught is the y-intercept, plus b1 times x, where b1 is the slope. This should look, if you've taken algebra, which most of you have, which is similar to the y equals mx plus b. It's the regression line, or the line intersects the line where x is equal to 0. And sometimes it's appropriate to interpret. And I'll go through on average based on the estimated value of the slope. So whatever this number is, so say the number is 2.5. If x increases by 1, then y increases because it's positive on average base, or increases on average by 2.5. Okay, so let's go through a couple of examples of this here. So this is where we have this is the crocodile data, where we're predicting body length based off of head length. Okay, so when we calculate it, what we do is we get a predicted y, which is equal to negative 18.274 plus 7.60 times x. Okay, and you can calculate this either using Excel or SPSS. Here's an example of an Excel output. This is similar to what you would see, or SPSS output, similar to what you'd see in Excel, where it's under this part here where you would get your y-intercept and where you get your slope. Okay, so in this case, this is where, and so we put it out in the equation, the 18.274. Well, this is inappropriate to interpret, since you can't get a negative body length, and the head length is never equal to 0. So outside, and typically we only use the y-intercept we have the y-intercept for our equation, but in terms of interpreting it, it's only interpretable if it's within our range of data, or if it's close to our range of data. But in this case, it's not. And this is, hopefully this is intuitive, that this would make sense to interpret. However, the slope we can very easily interpret as the head length increases by 1 foot, and this is where we get our slope. Okay, and so what we say here, how do we interpret that? So maybe what we should do is stop the video and figure out how we would interpret the y-intercept and how we would interpret the slope. Well, the y-intercept, since number of powerboats is 0, the number of manatee killed is negative. That can't happen. So this would be inappropriate. To determine to interpret 1,000 powerboats. The number of manatee killed on average increases by 0.129. Okay. So now let's talk about predictions. So we can take this linear regression equation, y hat equals b naught plus b1 times x, and we can predict something. Okay, we can use, for instance, let's use the example of the body length of a crocodile. When the head hat, which is our predicted y, we would have a predicted body length. Okay, so if we, for instance, if you use this in Excel or SPSS of this, so the head length. So here's a scatter plot here, where this is our head length, which is about it is at 441 at the line. Okay, so now let's go through another example. Predicting manatee killed in a year, given that there are 800,000.
Did you find something online?
Into Excel or SPSS, we can get a formula of a 60.788, really 1,000 that it goes up. Okay, if you notice down here in the labeling. And so this is just those of you who have, you can do this both in Excel, and those of you who use Excel can get the instructions from the online textbook or from your instructor. But basically what this is that this equation here is represented, as I alluded to earlier, is represented by this line. So this is what's called the predicted line. And so we can use, typically within a range of data, we can predict, in this example, the head length we can, predict the body length based off the head length. So this line is, as our head length increases, so does the body length, and it increases by, on average, when the head length goes up by 1. The body lengths are, as we increase our the number of powerboats by 1,000, the number of manatee kill on average is 0.129, and so it's gradually increasing. So both of these, if you remember from the previous lesson, these are both positive and strong linear relationships. We needed to get R to see how strong it is, but they look fairly strong without looking at R. But it would be wise to check R to see how strong our relationship is. We know it's positive and it's likely to be linear, but we should check to see how strong it is using R. So that concludes the video dealing with simple linear regression. If you have any questions, please speak to your instructor or to one of your TAs.
Okay, we just have to guess. They didn't say. So if we look at what they're looking at, they're looking.
Feel really good about 139.
You're thinking it's both of them?
No, one.
Is that how many? Gracious. Oh, that's how many combos. Okay, I gotcha. I'm thinking that it would be, yeah, I think you're right. I think it's.
It only makes sense if it's either that or double 139, which is what, 2.
Yeah, I'm thinking because they're looking at the scenario and seeing the both variables in the same scenario. Okay, sorry. And the y-intercept was 1.296.
Where are you getting that?
Wait a minute. Y-intercept. Oh, that's B. B. So I'm looking at the linear regression thing.
Mm-hmm.
And it says, but there's 2 of them. Hold on. What am I? Let's see what
I
it
was
says.
assuming that it's in H13.
H13. Yeah, well, that's what I'm looking at, but I don't know if it's that one.
I have 18.69 there.
Oh, whoa, you have totally different numbers? What?
What number do you have in A4?
A4 is 50.
Go back and look, double check, make sure
Do I have wrong?
one of us is wrong. So they tell us which one to put in as the explanatory and which one is the response variable. And it's actually, I thought it was reversed to what they had in the original.
Oh, I may have reversed it. So
you do need to reverse it, is I think what it is. Let me go back.
So I have the score is in column B, and the confidence rating mean is.
In question, just above question 6, it says, for the next 7 questions, use the data file. Be sure to use the confidence data for the explanatory variable and the score data as the response variable.
Well, good job for noticing that, because I did not. So that was.
I'm just hoping that then have the same numbers showing.
All right. Aha! Now it matches. So the y-intercept on, if I look under B, is 18.69, which is what you said, right?
Yep.
How? Well, that's a standard error, so I guess B is. I don't know which one. Why it's okay. The slope is 12.695.
Yeah, would that be 12.7?
Yeah. To 3 decimals. Yeah, it'd be 12.700.
Just look it. You get the biggest
Okay,
piece.
so then question 11 is, what is the predicted value of y when x equals 4? So I went to cell G18 and changed x from 6 to 4.
Yeah. There's this. So if x equals 4, then what's the answer? We're looking for the predicted value of y. I see the predictive interval.
Is the one right next to it that says predicted, is that
Oh,
the
right
predicted value?
Oh, excuse me. Oh, man. 9.47. So 69.47.
Yes. If that's the right one.
Well,
mean, yeah, totally the right one.
If we calculate it, it's what we know x is 4. And the slope is 12.695 for calculation purposes. And the y-intercept is 18.69. So let me just verify it and see if we're on the right track here. 12.695 times 4 is 50.78 plus 18.69, 69.47. So yeah.
Nice.
They add up. All right. Okay, the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value?
So the max score was 6. So I just changed the x equals back to 6, which then gives us the 94.86. For the what?
These values of x. So it's, where is it? 94.86 would be the maximum. Oh, we're not asking for the minimum. Okay. How many independent variables are present in simple linear regression? Isn't it 1?
That's what I was thinking, but I hadn't checked it yet.
Let's see if the text tells us simple. The question is explanatory independent variables. Wonder if it's in the summary. Sometimes that stuff is just in the summary. Or both those values. No. Doesn't say.
Fit line to data. This provides a powerful tool to model bivariate data, i.e. data involving 2 variables. So 2 variables.
Yeah,
so
well, yeah, so if it's simple, there's only one independent variable, and if it's multiple, then it's more than one.
Let me read on here. Regression allows us to write a linear equation that models the relationship between the independent variable x and the dependent variable y, which we can use to protect the value of y for any given variable. Let me go back to the question. How many explanatory independent variables are present in a simple linear equation? So, and I think it's one on dependent too.
It is, yeah. Like I'm looking at section 4 where it introduction to multiple regression, and it's basically stating that if you have more than one of either one, it's going to be a multiple regression, and then you need to hire a statistician. It's more complicated. That answer cracks me up. Let's hire a statistician for that. So yeah, I think it's one on both of those.
Okay.
All right. A company in South Dakota manufactures hard hats used in mining yesterday. Record measurements on hats quality control. Hat size, circumference, and the length of meaning can watch predict size of hat given the circumference. What is a response variable? Okay, so they want to predict the size of the hat. So hat is Y, right? I mean the size. Size of the hat is Y. That's the predictive.
Yeah.
So which one are we checking out? What is the response variable? It's the one that's affected by what happens to the size of the hat. Right? Okay. The size of the hat, because it's the variable being predicted.
I feel like it's either A or C.
The size of the hat is what would change given the circumference. Wait. The size would change based on the circumference changing. I think, yeah, the response variable is the dependent variable because it's dependent on the circumference. The size of the hat is dependent on the circumference. So is it because it's the variable being predicted or because it's being used to predict? It's because it's the variable being predicted. It's A, I think.
That's what I think.
Okay. Sorry. You're nice to let me talk it through. Yay.
See how we did. And missed one.
Oh, what did we miss?
We missed number 10.
Number 10.
At least I did.
So did I. It's not. So I'm wondering if it's how we wrote the answer. Like I did 12.700. I'm wondering if we're supposed to do.
I did just 12.7.
I wonder if we put in 12.695 because we're not round. Yeah, we shouldn't have rounded because we don't know what the fourth number is. I bet that's it. Because you only round, if we're rounding through the 3 decimals and we know all 3, I don't know. I'm just guessing. I'm going to try that. Unless something else comes to my mind before I finish this.
You said 12.695?
That's what I'm thinking, yeah. Because that was the number on the spreadsheet. Mm-hmm. If I'm going to double check that, but I think it was. Okay, so it was 2.0, 1.5, 1. Hot dog shape. A. Triangle 39. Y-intercept. Down here. 18.69. Slope, so 10 is the one. Okay, 6. 13 is 1. 14 is 1. 15 is A. So did you check the spreadsheet and double check it? I was going to check, see if it.
Yeah, it's
95.
well, 695.
Okay. Let's see if it changes it. I'm okay only missing one, but if we're gonna get a stinking 40 and a 65 and those don't change, oh man, I gotta bring up the grade. Okay, yeah, that was what it was.
Okay.
Cool deal. That was it. All right, so that's done. It's submitted.